Here are the solutions to our practice test. Now our practice test bears a very strong resemblance to our actual test tomorrow. So if you can do well on this and understand the concepts in this test, then you should do quite well tomorrow. Anyways, we're asked to expand and simplify, so we'll just use our FOIL method. X times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. Collect our like terms. 3x plus 2x gives us 5x, for a final answer of x squared plus 5x plus 6. 3x plus 4 to the exponent 2 can be rewritten as 3x plus 4 times 3x plus 4. 3x times 3x is 9x squared. 3x times 4 is 12x. 4 times 3x is 12x. And 4 times 4 is 16. Collect our like terms. 12x plus 12x is 24x. So we get 9x squared plus 24x plus 16. Question C, 3x times 2x is 6x squared. 3x times 5 is 15x. Negative 2 times 2x is negative 4x. And negative 2 times 5 is negative 10. Collect our like terms. 15x minus 4x is 11x. Leaving us with 6x squared plus 11x minus 10. Question D, x squared, x times negative 7, negative 7x, negative 5 times x, negative 5x. Negative 5 times negative 7 is positive 35. Negative 7x minus 5x is minus 12x, for a final answer of x squared minus 12x plus 35. E, x times x is x squared. X times 2 is positive 2x. Negative 2 times x, negative 2x. Negative 2 times 2 is negative 4. Our 2x and negative 2x cancel out, so we're left with x squared minus 4. Question F, x minus 4 to the exponent 2. So we can rewrite this as x minus 4 times x minus 4. X times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4 times negative 4 is positive 16. Collect our like terms. Negative 4x minus 4x gives us negative 8x, for a final answer of x squared minus 8x plus 16. Common factor each of the following. So we need to find the greatest common factor between 5x and negative 15, and that just happens to be 5. So we put our 5 down, and then we open our brackets. 5x divided by 5 is x, and negative 15 divided by 5 is negative 3. Question B, 24x squared plus 16x. Now we have x in both of our terms, but let's start with the numbers. What's the greatest common factor between 24 and 16? And that happens to be 8. What is the smallest exponent between x squared and x? That happens to be x. So our greatest common factor is 8x. 24x squared divided by 8x is 3x. 16x divided by 8x is negative 2. Question C. Once again, we have x in all of the terms. So we have an x cubed, an x squared, and an x. But we'll start with the numbers. So the greatest common factor between 14, 7, and 21 happens to be 7. The smallest of the x exponents between x cubed, x squared, and x happens to be x. So our greatest common factor becomes 7x. 14x cubed divided by 7x is 2x squared. Negative 7x squared divided by 7x is negative x. And 21x divided by 7x is 3. Factor each difference of squares. Well, we're told that each is a difference of squares, so we can take some comfort or knowledge in that. So what we need to do is, in question A, what is the square root of x squared? Well, that happens to be x. So we'll write that down. Now, what is the square root of 36? That happens to be 6. So we'll put those in. And now all we need to do is put in a positive and a negative sign. And we've got our final answer. Question B, 9x squared minus 64. Well, let's look at the square root of 9 first. We'll do our numbers. So the square root of 9 is 3. And the square root of x squared is x. So the square root of 9x squared is 3x. So we'll write that down. Our square root of 64 is 8. So we'll write that down. And now all we need to do is add our negative and positive signs. And there's our final answer. In question C, we look for the square root of 49, and that happens to be 7. So we'll write that in. What's the square root of x squared? Well, that is x. So we'll write that in. And then we'll write our positive and negative signs. And there's our factored form. Factor each trinomial. So question A, x squared plus 7x plus 10. We're looking for two numbers that will multiply to 10 and add up to 7. So the multiples of 10 are 1 times 10, 2 times 5, and the second one, 2 and 5, add up to 7. So we can factor this by saying x plus 2, x plus 5. In question B, x squared minus 2x minus 35, we're looking for two numbers that will multiply to negative 35 and add up to negative 2. So we'll write in our factors of negative 35, and then we'll look down our list of pairs and see which ones add up to negative 2. And that just happens to be 5 and negative 7. So our factored form will become x plus 5, x minus 7. X squared minus 7x plus 12. We're looking for a pair of numbers that will multiply together to be 12 and add up together to be negative 7. Here are our factors of 12. So we look down our list of pairs until we find something that will add up to -7. And that happens to be -3 and -4. So our factored form becomes x minus 3, x minus 4. Fully factor each of the following. Each question requires 2 types of factoring. Now, when faced with a question that tells you that there's going to be 2 types of factoring, usually this means that we need to find a greatest common factor to begin with to reduce this into some sort of form. So, what is the greatest common factor of 2x squared plus 2x minus 12? Well, the greatest common factor is 2. So we'll write that 2 outside our brackets, and by greatest common factor we'll get 2 times x squared plus x minus 6. Now we look at what's inside the brackets. We're looking at the trinomial inside the brackets, and we want to see if we can factor this a little bit more. So this is not a difference of squares, so that won't work for us. But we can look for 2 numbers that will multiply together to be -6 and add together to be 1. So our multiples, our factors of -6 are listed here. And now we're just looking down our pairs until we find one that will add up to 1. And that just happens to be the pair -2 and 3. So our factored form will be x minus 2, x plus 3, but we can't forget our greatest common factor of 2. So we need to add that from this step up here so that we're got a correct answer. So we'll take that 2, we'll put it in front of the x minus 2, x plus 3 for our correct answer. Question B, x cubed minus 64x. Well, our greatest common factor here is x. So we'll put that down in our brackets. X times x squared minus 64 is our partially factored form. Now if we look inside the brackets, we can see that we have a difference of squares. So we can continue factoring in a bit more. Square root of x squared is x. Square root of 64 is 8. Put in our positive and negative signs. But we can't forget the greatest common factor of x, which we need to put in front of the brackets for our completed answer. (3x squared minus 48). Well, we have a greatest common factor of 3, so we can start to factor it and end up with 3 bracket x squared minus 16. And now once again, within the brackets, we have a difference of squares. So the square root of x squared is x. The square root of 16 is 4. Put in our plus and minus signs. And don't forget to add our greatest common factor to the beginning for a completed answer of 3 bracket x plus 4 bracket x minus 4. The dimensions of a rectangular bedroom can be written as length equals 2x plus 1 meters and the width equals 3x minus 3 meters. Draw a sketch of this problem and label each dimension of the bedroom. Well, there's our length, 2x plus 1. There's our width, 3x minus 3. Question B asks us to determine the trinomial expression for the area of the bedroom. Well, if these are our width and our lengths, and the area is length times width, then we'll simply multiply 3x minus 3 by 2x plus 1. And when we FOIL that, we end up with a trinomial of 6x squared minus 3x minus 3, which is what our area is. Question C tells us that if x equals 4, what are the actual lengths and width of the bedroom? So we'll just take that 4, we'll plug it in for the length, ending up with a length of 9, and our width, which also happens to be 9, which tells us that our bedroom is actually a square. So if our length is 9 and our width is 9, we can plug that into our trinomial and find out what the actual area of the bedroom is. That's going to work out to 81 meters squared. The area of little Tommy's backyard sandbox is x squared minus x minus 20 feet. Factor the trinomial to find the expression for length and width. So, we are looking for two numbers that multiply to negative 20 and add up to negative 1. So our multiples are all of these pairs. And we look down our list until we find one pair that add up to negative 1, and that happens to be 4 and negative 5. So we can write our factored form as x plus 4, x minus 5. Now B, is the shape of Tommy's sandbox a square or a rectangle? How do you know? Well, if it was a square, then both the length and the width would be the same. But if the length is x plus 4 and the width is x minus 4, they are not the same. So we have to assume that it's a rectangle. And then we're asked in question C to calculate the area of the sandbox if x equals 8. So all we need to do now is just plug in 8 for the value of x. And we get length of 8 plus 4 is 12. Width is 8 minus 5 equals 3. Length times width is 36. Write a binomial that has a common factor of 2x. Well, we can write this just by putting a 2x in front of some brackets and then just writing a binomial inside the brackets. So there's our common factor on the outside. Here's a binomial of some sort on the inside. And when we multiply it out, expand it, we get 2x squared plus 6x. So 2x squared plus 6x is an example of a binomial that has a common factor of 2x. Question 9 asks us to write a trinomial that has a common factor of 5. Well, once again, we can just write our 5 on the outside, and then inside the brackets, write just about any trinomial. So in this case, I chose 2x squared plus 3x plus 5. Once I multiply it out, I'm given a trinomial of 10x squared plus 15x plus 20. So this is an example of a trinomial that has a common factor of 5. Question 10 asks, Is x squared minus 76 a difference of squares? Explain why or why not. So for it to be a difference of squares, the first term has to be a perfect square, the second term has to be a perfect square, and it has to be separated by a negative sign. Well, x squared is a perfect square. It is separated by a negative sign, but 76 is not a perfect square. Therefore, this is not a difference of squares. Shanna is factoring x squared plus x minus 6 and decides that she will use 3 and negative 2 as her values, so the factors become x plus 2, x minus 3. Expand her answer to show she was not correct. Where was Shanna's mistake made? All right, so we're looking for a pair of values that will multiply to negative 6 and add up to 1. So our factors of negative 6 are not, in fact, 2 and negative 3, because if we expand this out, we'll get x squared minus x minus 6. I believe Shanna could have gotten the correct answer if she used x minus 2, x positive 3. That would have given her the right answer. Harold says that x squared plus 25 can be factored. Janice says it cannot. Who is correct? Explain your reasoning. Well, I imagine that Harold probably thinks that this was going to be a difference of squares. X squared is a perfect square. 25 is a perfect square, but it's not separated by a negative sign. So, sorry, Harold, you're wrong.